So this question is about an organic reaction mechanism. Related topics include organic reagents and conditions, naming and drawing organic molecules, reaction mechanisms, specifically the terms nucleophile, electrophile, addition, substitution and elimination reactions, and curly arrow notation. Reagents and conditions at the top of the list, are really a lot of marks to be gained just by knowing the content. And naming and drawing molecules, similar really. Practice them, know your functional groups, and being able to name them is going to enable you to pick up marks and also help you to understand the majority of organic questions. So pause the video, read the question and have a go. Press play when you're ready for the answer. The convention that I will be using is black, the question itself, blue, the model answer, and red, any additional information. So curly arrows show the movements of a pair of electrons. This is always linked to forming and breaking of covalent bonds. A nucleophile is an electron pair donor. An electrophile is an electron pair acceptor. Okay, so we won't actually ask for the mechanism in this particular question. However, I'm going to explain it because I think it's such a useful mechanism and one that you could be asked for on other papers. Knowing that 1-bromo-2-methyl-propane has got that structure, so linking the structures to the name is an essential skill. So we've got 3 carbons in the longest chain, bromine atom on carbon number 1, and there's a methyl group on carbon number 2, a CH3 on number 2, so the propane is linked to the 3 carbons in the longest chain. I'll say again, reagents and conditions, absolutely essential. So under these particular conditions where we've got ethanolic potassium hydroxide, we don't get the substitution, rather we get the alkene being formed. We'll name the type of mechanism in a moment. So the alkene is formed under these conditions, and 2 other products are given as well. So the bromide is there and also H2O. So we know that the hydroxide is provided by potassium hydroxide, and that must bond with one of the hydrogens in our reactant molecule to make the water. So there is the hydroxide donating a pair of electrons to form a covalent bond. The carbon to hydrogen bond must be broken, otherwise the water would not be a separate discrete molecule in the product there. So there is the carbon to hydrogen bond breaking, and that also is linked to the formation of a carbon to carbon double bond. The bromide is obviously not linked on the right hand side, so that carbon to bromine bond must be broken, and that arrow on the left there shows that the carbon to bromine bond is broken, and the pair of electrons, the 2 dots are shown there on the bromide ion. You can put the delta plus and the delta minus charge in there. In terms of the type of reaction, we started off with one larger molecule and made some smaller molecules and an ion. So this is known as an elimination reaction. So we can think of the water as being eliminated. It's like the reverse of an addition reaction. So a larger molecule makes 2 or more smaller molecules and substances. Whereas in addition, we have 2 smaller molecules making one larger molecule. The name is methylpropene of the organic substance. So there are 3 carbons in the longest chain. The carbon-carbon double bond, the alkene functional group, is given to us by this propene rather than propane or anything like that. And there's a methyl group on carbon number 2. We didn't have to number this because there's no other configuration. There's nowhere else that we can put that double bond, and there's nowhere else we can put the methyl group. However, 2-methylpropene was allowed. Got the opportunity to have a look at another question now, so please pause the video, read the question, have a go, and press play when you're ready for the answer. Okay, welcome back. So just a quick naming question, this one really. You have to know your functional groups. In this case, we have an aldehyde. There are 4 consecutive carbons in the main chain, hence the bute. We have propan in the previous question, so now we've got butan in this one. So we need to know that is linked to 4 consecutive carbons. The functional group, in this case, the aldehyde functional group, must be on carbon number 1. And skeletal ends and bends are carbon atoms. So there I've got 4 carbons, 1, 2, 3, 4 in the longest chain, there is a methyl group on number 3, and the aldehyde, that CHO functional group, is on carbon number 1. We weren't asked to give that sort of, well, I've given a combination of displayed and structural there, but we were asked actually for the skeletal. And so ends and bends are the carbon atoms, and oh, there it is. So we've got 4 carbons in the longest chain, methyl group on carbon number 3, and a C double bond O. Thanks for watching. New videos are added regularly. Subscribe if you don't want to miss out. Questions about this video and requests for future content are very welcome. You can email, use the email address on the bottom of the screen, or post in the comments. Take care.